In this example, let's sketch the graph of the rational function f of x equals 1 over x squared plus 1. To sketch our graph, we need to find the y-intercept, the x-intercepts, the vertical asymptotes, and the end behavior. Let's start with the y-intercept because it's the easiest. To find the y-intercept, we look when x equals 0. Evaluating our function, we get that f of 0 is 1 over 0 squared plus 1, which is just 1 over 1, which is 1, leading us to the y-intercept 0, 1, which we can put on our graph. For the x-intercept, we want to look when our function is 0, y equals 0, which means that we need to solve the equation 0 equals 1 over x squared plus 1. But for a fraction to be 0, we need the numerator to be 0. That is, we need 0 to equal 1. But we'll never be able to solve 0 equals 1, which means that we don't have any x-intercepts. Now for the vertical asymptotes, we want to find when x squared plus 1 equals 0. Our denominator is 0. But this also has no real solutions. The solutions are plus or minus I. So this means that we don't have any vertical asymptotes either. Now, for the end behavior, we want to see what's happening when x is going off to plus or minus infinity. For this fraction, as x gets very large, the denominator x squared plus 1 also gets very large. So the fraction as a whole, 1 over x squared plus 1, is approximately 0. We saw before that we should always expect this when the degree of the numerator is smaller than the degree of the denominator. So this tells us, on the ends, our graph looks like the line y equals 0. Now, since there are no x-intercepts and no vertical asymptotes, f of x cannot change sign, which means our function must always be positive, pass through the point 0, 1, and on the ends just look like 0. So sketching this graph that has these properties, passing through 0, 1, and close to y equals 0 on the ends, we get the graph of our function 1 over x squared plus 1.